Ever wondered how to supercharge your Linux system's performance for gaming, low latency, or power savings? Meet SCX schedulers, the revolutionary feature in openSUSE Linux that takes your system to the next level. Let me show you exactly how to use it at home. What is a scheduler or CPU scheduler? A scheduler is a critical part of an operating system responsible for determining which processes run on the CPU at any given time. It ensures efficient allocation of CPU resources, balancing performance and responsiveness. CPU schedulers are part of a broader framework of process management, which includes creating, managing, and terminating processes as well as handling memory allocation, memory management, and process management as building blocks. Memory management involves allocating and managing the memory space for different processes, ensuring each process gets the resources it needs without interfering with others. Process management organizes how processes are initiated, scheduled, and executed. The CPU scheduler is a key element of this system as prioritizes and queues processes for execution. In this video, we will see how the SCX framework enhances the CPU scheduler, allowing you to tailor your system for specific tasks like gaming, low latency, or power efficiency. What are SCX schedulers? SCX stands for Scheduler Extensions or Service Class Extensions, a cutting edge framework integrated into the Linux kernel to dynamically load thread schedulers using BPF Berkeley Packet Filter. These schedulers allow optimized performance for specific tasks like gaming, low latency, or power saving. What is OOB support? OOB stands for out of band. It extends kernel functionality beyond standard Linux features, allowing advanced scheduling. You can verify OOB support on your system by running this command. If your kernel supports it, you will see config underscore sched underscore class underscore ext equal y. And this command zcat slash proc slash config.gz and we pipe it and grep schedule class extension. Why use SCX schedulers? 1. Optimize workloads, perfect for gamers, developers, and home users. 2. Achieve low latency and power efficiency effortlessly. 3. Flexible customization with real-time configuration. For an example, imagine running a game on a laptop with SCX. You can maximize FPS frame per second while reducing power consumption. Run the following command to install SCX. This command ensures you get SCX with all its recommended features. You can install this package bpftool to monitor SCX performance. To launch SCX manually, I can write sudo space SCX underscore, and if I press tab twice on bash, it will list all the installed and available schedulers to use on my system. I'm not going to cover them all, and I will talk about a couple of them. Here I ran the Rusty scheduler. This starts the Rusty scheduler and replaces the default kernel scheduler. To stop it, you can press Ctrl C. The default scheduler will automatically resume. SCX integrates with systemd for automation. The configuration file under slash etc slash default slash SCX. So now let's open the file and we can see here the default is bpfland. Change the SCX scheduler to SCX underscore lavd for gaming optimization. Don't forget to save the file and exit. Enable and start SCX scheduler at boot by running sudo system control space enable space dash dash now space SCX. You can start SEX for the current session by running the same command, but instead of enable now, just start. And you can stop it later by using stop, system control stop, SEX. A few schedule recommendations. SCX Rusty, robust global scheduler for general purpose workloads. For example, running multiple video editing tasks without system lag. SCX LAVD, designed for gaming and handheld devices. The limitation lacks topology awareness. For example, AMD Ryzen 7950X CPUs with two CCDS. Let's explain what is CCDS. In modern AMD Ryzen processors, especially those with thin architectures, for an example, Ryzen 7950X, a CCD, core complex die, is a building block containing multiple CPU cores, cache, and other resources. Each CCD operates semi-independently and communicates with other CCDs via a high-speed interconnect called the Infinity Fabric. When a scheduler lacks topology awareness, it may treat the CPU as a uniform block without understanding these separate CCDs. This can result in suboptimal task allocation, such as assigning threads across CCDs instead of within a single CCD, which increases latency due to cross CCD communication. For real life implications, for example, in gaming on a Ryzen 7950X, if tasks are spread across CCDs, it might introduce delays due to inter-CCD communication. A topology-aware scheduler would localize the workload within a single CCD to leverage lower latency and better cache utilization. For an example for this scheduler, SCX LAVD playing a high-performance game on a Steam Deck. And we have SCX Rustland, utilizes user space scheduling for heavy workloads. The trade-off, increased overhead due to user space involvement. Example use for this scheduler, rendering a 3D model while compiling code simultaneously. Let's take a practical demonstrations here. First, check your kernel for SCX support by running this command zcat/proc/config.gz and pipe it to grep schedule class extension. The output should be config schedule class extension equal y or yes. Next, change the scheduler by editing the file /etc/default/scx. Here we change it from bpfland to scx_lavd. And then restart the scheduler by running the command sudo system control restart scx. For some real-world use cases, for gaming, switch to scx_lavd for smoother gameplay, and for power saving, use scx_bpfland for laptops on battery. And here are some tips and lesser known features. SCX schedulers can be dynamically switched without rebooting. Custom BPF scripts can further fine-tune your scheduler behavior. You can monitor SCX performance using the scheduler command, and you can use bpftool utility for inspecting and managing APF or extended Berkeley packet filter programs and maps in the Linux kernel. Here I will run the command and I will pipe it to this command to see the output. If you are interested in learning more about SCX scheduler or how to use bpftool to monitor and optimize your system, make sure to check out the following links. First, you can head to the SCX scheduler GitHub link and make sure to read and check the README file. And also you can check this link from CacheOS. They have a nice tutorial about schedule or SCX scheduler. You can check the tutorial for more information. And when it comes to bpftool, you can check this link. It gives more detail about the command. I will leave the links in the description below. To troubleshoot, check logs for errors by running this command sudo journal control space -u space scx. Some of the common issues: missing kernel support, for example, update your kernel to the latest version. To summarize benefits, SCX schedulers empower you to take control of your Linux system's performance. Try SCX today and share your experience in the comments. Don't forget to like, subscribe, and hit the bell icon for more Linux optimization tips. See you next time. Thanks for watching.